Finland.
Thank you. As some of you know, I'm a big fan of Lego. Rick probably knows. I try to push my kids to build more Lego, like it's the only reason that I can then buy more Lego, but that's it's just having a valid excuse.
You told me you don't let your kids touch your Lego.
Coming to that.
Oh, sorry.
So this is a picture of my son's bedroom, and this is actually one of my first Lego sets I got from my parents. I've built this with my father, my mother, and I now built that with my sons. It's actually a set of 1994, the pirate ship. And while I was building that set, some smart people at Sun Microsystems released what is called the fallacies of distributed computing. It's a set of misconceptions that developers, architects, and people that are building or designing distributed computing systems make when they are doing that work, that architecture work or that development work. So these are these fallacies. I'll give you some time to take those in. So most of these fallacies still apply to this day when building distributed systems. Most of them have evolved to be something else, but they still drill down to the same core principle. And that's what we are going to talk about today, and based on experience I've had when helping a customer building a data API platform on Azure. Little disclaimer, also, not all the knowledge will be in this session. There is no silver bullet when building systems on the cloud. It's a fallacy, so it's... So we're going to talk about today, and I don't know where this is going to end up, but join me for this ride. So I'm Glenn. I work for Azure Belgium. If I'm not doing stuff on Azure, I'm hugging polar bears. I'm a happy fella of this crew. I'm here in the middle, shouting at people, and as... Sorry? You look funny as well. And like Saki said, we have a bunch of cool logos from Microsoft. So that's about it. So let's talk a bit on the project here. So the case that we're going to discuss today is Nexport International. They're a data and API platform based on the Port of Antwerp. And they are trying to, the goal there is to improve the logistic chain and improving collaboration overall between every party involved within that entire chain. For example, if you ship a good from the US to Europe, for example, sometimes more than 10 parties can be involved in that entire chain. So if we take a look at the industry itself, at the entire logistics, many of the companies there still operate in silos. So they're very on their own. They have all the data necessary or all the processes in place to work on their own island. And that's a bit of a problem. The entire industry on its own is also still very based on paper. People that are doing truck movements or need to do truck shipments still have to have a paper-based declaration of the goods that are in their truck. IT legacy is still a big problem in that entire industry, and of course, they're still using one of our favorite programs, Excel. It's still heavy based on Excel, and yeah, you see IT legacy is a big problem there. So as said, Nextport is trying to change that mindset by really bringing those partners together and transforming the entire collaboration. This is important as companies to remain relevant in this world because the world is changing. There's more and more regulations coming. We see a new trend of renewable energy popping up also in the supply chain. And therefore, for those logistic companies, it's important to remain on the edge of technology and try to shift a bit in their mindset and to solve their problems when they are working with the data they have. And as said, to solve problems, you need data. And a lot of, as said, the companies operate in their own silos, so they perfectly know where their own data is, and they perfectly know how to work with their own data. But to really have visibility across that entire chain, we needed that data from other parties, we need data from other sources, we need data from that entire chain. All of that data in a fairy tale world, all that data would have the same format, everybody would use standards, but of course that's not it. So the ultimate goal of the platform is to really bring that data together, to harmonize that data, to chain it, and to have a visible end-to-end view on that entire logistic chain, that entire shipment, or that view across all the partners. So it's really about bringing parties together and making data accessible for anyone who is authorized. And that's a key figure there. So not everybody is allowed to see certain shipments or containers or anything else. When you ask data to the platform or you put data into the platform, you need to prove that you're allowed to see that data, or you need to prove that you are eligible by the people putting data in the platform, that you are allowed to see that data. More on that later. So some statistics. So the platform has been in production for half a year now. And on a monthly basis, we're processing around 1.7 million outbound messages, handling 2.2 million API calls. We handle truck movements within the port of Antwerp. Truck movements like if they need to go and do a cleaning of tanks. So we handle that through the platform. We handle shipments, and we have around 1,000 users on the platform and 100 global big companies registered on the platform, consuming our APIs, exchanging data, and using the platform as we go. So on the architecture. So how we started designing this platform is we initially started talking with the stakeholders. And there they gave us some key focus areas or some things that were important for them, but also for everyone else. So identity and access management was crucial. So we're working with external users, people with external identities, and it was important that everybody could register without any holdbacks. We had a vision of being an API-first platform. So we really tried to change the world and tried to force everybody to go or to come into the platform through APIs. That might have changed over the months, but more on that later. So the people at Nextport really aimed to be as close as standards as possible. They didn't want to have many modifications, so it was a focus area that we need to be as close to standards or to using standard services as much as possible. Data security was also important. Data needs to be secured because we're talking about sensitive data for parties involved. And of course, this is a Microsoft conference, so our focus was everything on Microsoft and on Azure in particular. So when doing the architecture, and this is an exercise we usually do when starting to build up, is to build up that architecture or that use case in layers. What we first did was starting out by mapping the actors on the platform. So who are my users of the platform, who is consuming the platform, and who's involved. So here you see it's actually a pretty simple architecture. And if you start doing that exercise for the platforms that you are going to build, this is usually the most easiest drawing to be done because there's usually not that many actors involved. In our case, we had data providers that are people that are pushing data in the platform, data consumers, as the word says, they are consuming the data. Then we have users that are using our portals, our configurations, and on the bottom we had the administrators that could configure certain settings of the platform, could approve registration of users, of companies, and so on. The next step what you do in this case is to open up that box in the middle. So your platform. So you have your platform in the middle. Let's start opening up that box. So we open up the box and we mapped out further, like we needed data ingestion. We needed products. Products in the sense, in this case, this was APIs that we hosted on the platform or applications that were hosted on the platform. We needed a public API. We needed data vaults. Data vaults as the way we securely store our data within the platform. We needed customers or some logic to register customers, to handle those companies. We also needed some internal API and then some use cases that were hosted on the platform. When you have this drawing ready, you need to start thinking, okay, is this my final level of detail which is ready to do my architecture? In our case, it wasn't. We further drilled down and opened that ingestion box once more to, we needed routing, we needed channel configuration, and so on. So this is an example that you can use when you start building out an architecture. So don't start with immediately going through the technical components, but start with the really high level. Who are your consumers of the platform? Who are your actors? What's the goal there? And then start drilling down more towards the technical side. In the end, our architecture looked a bit like this. So Rick built this morning, so thank you. No, all jokes aside, it was pretty funny that during Rick's session this morning, it shows that many of the components or many of the solutions that we've built come down to a basic set of components. And if you know those basic components like Azure AD, API management, Cosmos DB, app services, you can come a long way. And all jokes aside, this is what its high level really looked like. So on the top we have 2 portals, we have API management, we have our authentication layer having Azure AD and Azure B2C. I'm coming back on that later. We have an API layer, data stores, processing layer, some supporting services, and in the bottom we have several use cases that are, let us say, mini applications that are using the core services of the platform. Here is one fallacy that we try to mitigate. There is one admin. No. Be aware of this concept that there is no platform out there that is, or that can be supported by one person. Make sure that if you're working in a team that many people can support this platform, you can have multiple people working that out. In our case, we not only had multiple people administrating the portal, each of those components are also separately deployable and can live next to each other or have another independent lifecycle. So that's also important when you take that from the one admin approach. So identity and access management. So we're in this part. We started this platform, I think, year and a half, 2 years ago. And then the choice of technology was pretty clear. We had to use external identities. So Azure B2C was an easy choice. Like in Rick's session this morning, Azure B2C written down. But then, I believe it was somewhere last year, Microsoft announced Entra External ID or whatever it's called. And then we had to start rethinking our strategy. Okay, how does this impact us? Is Azure B2C still a valid choice? Is it not? Do we move everything to Entra External ID? And here's another fallacy. If you're building software or platforms or cloud platforms, be aware that change is coming. Topology will change. Services will be deprecated or will have another name in the end. So Rick mentioned this morning that most of his friends are still recommending Azure B2C. And I want to dig a bit deeper on that. So if you compare Azure B2C with Entra External ID, so Azure B2C is, from my point of view, there for your mature production-ready identity solution. It has support for the advanced authentication scenarios, and it has really the possibility for you to do some changes in the sign-up flow, change the pages, influence the look and feel of the pages. The only downside there is no support or less support for device code flow. And this is where Entra External ID comes into play, where we see that Entra External ID is a valid choice when you're just on your starting journey for production, when you don't have needs for immediately to go production or have really simple scenarios when you're moving to production. So be aware that new feature will land on Entra ID, but maybe also on B2C, as I saw some new features popping up like last couple of weeks. Where Entra ID stands out is the fact that it's more, it has more modern support for DevOps practices. It's easier to automatically deploy everything that's involved there. So that's a bit of the story. So we did a review there. We decided to stick with B2C. What we did is we started thinking about how you can prepare for migration. So a simple setup there, what you can do is you can create a custom user flow in Azure B2C. So when a user signs in or registers on the platform, you just take a copy of that user and insert it in Azure Entra external ID. It's too complicated, so don't migrate. The name is too complicated. So you can just insert that user and have like a user thing going on. So what we did, as already mentioned, we heavily modified the login experience for Azure B2C. And we used custom pages. And with those pages, you can start playing around with JavaScript and so on. So one of the key things there is next to having external users registered on the platform, we also have a couple of federations within B2C. And when a user enters his email address, it's basically, I see that it's not in English. This is, OK. So when a user logs in, he types in his email address. And the script behind the scenes, what it does is it goes and check our backend API to see if that email address is a federated account, yes or no. So based on that check that comes back, we completely changed the login page here. And that was a pretty cool exercise to do, bringing a more friendly support for our users. We also use heavily using custom scopes and claims, which are very easy to configure within Azure B2C. And how you can do this is by configuring an API connector. An API connector hooks up in the sign up, sign in flow, or when you sign in. And then you can do an API call within your process. And you can basically start enriching that data with different roles. As a role here, we mapped out our roles in this type of table. And until now, we were able to basically match out all the roles that a user, a company, or a community, or a data admin, company admin needs within the entire platform. We were able to map that out in this simple table. So what it does, it has a subject, it has a subject type. So the subject type tells about the subject, and then it basically gives you a role on a certain object. So and in that way, we were able to map out all those things. When using services or global services, just don't rely on them fully. Like we've seen, like from time to time, that login.microsoft online is not available for like split seconds. And if you do not have a backup within your system to support that, or there's no fallback, or you don't enable retries, then you might see some issues in your application. We also heavily use managed identities. I believe Rick also mentioned that this morning. It's for inter-service communication. It's easily revocable. It's managed by Azure. And those credentials are automatically rotated. Basically, you don't need to manage anything. However, also here, don't fully rely on the service being available. or don't rely on that managed identity working 100% at the time. I'd like to invite you to read this and then check the status code. Same thing happened here. At a given point, we saw a dead letter in our service bus queue with the error, authentication failed. Done. We didn't see anything, any clear, anything in our logs that figured that out. And when we digged a bit deeper, what happened is we tried to contact SQL from our application and just got an operation canceled exception. That was it. No further detailed logging. Our service just didn't start, or it failed. And you see that it failed on the get token. Here again, lesson learned: just don't rely on everything. Just make sure that you implement enough retries or have that fallback scenario. Messaging processing. So we're here. Some keys here is don't rely on the network. Again, so we're going to talk about within the entire platform, we heavily rely on queues and topics. I think most of you are familiar with that. So a queue is a first in, first out mechanism, while a topic is more of a publish subscribe mechanism where you can have multiple receivers of a message. We have a lot of partners that we integrate with or we need to send messages to. And as always, we fully rely on the network being available, so we just push that message down the throat of our partners. So that's not true. So we use something like store and forward pattern where when a message comes down or starts or enters our outbound function, so our function that is responsible for sending messages to external partners, the first thing that we do is we store it in a queuing system, and then that function will just start sending out messages towards our external partner. And to be honest, that has already saved our ass a couple of times. So we have seen outages on our platform, but also on the partner side, where there's a couple of hundred messages being blocked. So if you do not foresee that as you are building a platform, you will not be able to do this kind of things. So that outage there was done, and then we just took the entire dead letter queue and reprocessed that message. None of the data was lost, so that was a good thing. So bandwidth is infinite. So that's one on us, I guess. So we started out building the platform with the first couple of messages or the first iterations. We thought, we will only receive small messages in our queue. Let's be happy and start building that way. And that worked perfectly fine. Until the day came that we got an error on our queue. The message was too big to be put on the queue, so we had issues. So we knew that day would come, and then we introduced what was called the claim check pattern. Again, here what you do is when you receive a big message, You store the data with the key on a persistent storage. That can be anything that you want. I heard Postgres, I heard SQL this morning, so choose whatever you want. But the key there is that you store it, and then you take a reference to that message, and then add that reference to the queue, let it flow through your application, and then in the end, when you need to process the actual data, you're ready to go. Debt letters. That's another one on us. So a couple of months into the production, we noticed that most of the issues that we saw, or most of the debt letters we had, were business related, or like all of them. And we were like, yeah, we're getting too much alerts. Let's do the reprocessing, do the delivery attempt to 1, and then we only get business exceptions. And that quickly backfired in our face. Like, yeah, we saw that messages sometimes just fail because of network hiccups or any other hiccups. So we quickly decided to turn that around and to have some more delivery attempts configured on our messages within Service Bus. So another thing I wanted to touch is debt letters on topics. So we have a couple of topics within the platform where we have messages coming in, and that message needs to be processed by different functionalities within the platform. And sometimes it happens that something fails on one of those subscriptions, and it ends up in the debt letter. What we saw there, if you want to resubmit that message and you put it back on the topic, your other consumers will also receive that message again if your filtering is done in a very specific way, or it's very generic. So here's a thing that you need to be aware of, that if you have this type of setup, that you need to be aware that you implement item potency within your other application, or you are able to handle the message coming from the platform twice. So make sure that you are aware of that. Data processing. As already said in the beginning, we aim to change the world. We were forcing API connections upon our customers, and just saying, yeah, we only do API connections, and so on. But as you remember at the beginning of the talk, we are working in an industry that still has big IT legacy, are not that known for innovations and so on. So we quickly had to turn that around and started thinking about how we would reorganize our data ingestion flow. So classic on our side, what happens is we have an ingestion API, an API that allows users to put in data with the platform, which is exposed by API management, and then flows down to the other parts of the platform. So we had that API. So that was key of our entire like platform. Yeah, just if you want to send us data, API only. And yeah, then let us say some bigger players came into the equation, and then we had to turn things around. We had to introduce an I don't know if it's an official term, but we had to introduce something like protocol offloading. So one thing we had to support was AS2. And for people that know or have been in the integration space, like AS2 is still very commonly used. And it's sometimes it's painful to set up or to get that connection going. In Azure, you can use logic apps with an integration account to configure an AS2 connection. So the approach that we did there was, the goal of this, this setup was to allow partners to connect over AS2, but we decided to not put any business logic or any parsing logic within that system. So the main goal of that logic app or that setup was to just support the protocol and offload that data as soon as possible to our main internal, our main ingestion API. Same thing with SFTP. Apparently still a lot of companies use SFTP or FTP or something like that. But here again, we did not add any logic to that. The main goal of that SFTP or that function that was processing the SFTP message was to take in the blob that was on blob storage. So we're using, yeah, maybe I should mention that. We're using SFTP on blob. It's super simple to use, actually. We got a trigger when a message arrived, and as soon as that message arrived, we pushed it down our internal ingestion API, allowing to use basically the entire base flow that was already in place. The end goal of this is when those customers decide to ditch AS2 or SFTP or any other protocol that we support right now, that they can easily switch to the new system. Monitoring. If we look at our architecture, monitoring is key here. And as Rick discussed this morning, and as we already discussed today, Azure Monitor is a key service or set of services within Azure, allowing you to basically monitor everything that is going on within your application or within the Azure services itself by enabling diagnostic logs and so on. Correlation is key. Every time a user or a data provider sends us a message or puts data into the platform, we stamp it with a correlation ID. We happily provide that correlation ID back to our consumers. I don't know what happens with those correlations ID at their end, but more on that later. And when you take this principle and you stamp it with a correlation ID, and you let that correlation ID flow through your entire system, it's easy for you to really find out issues that are going on, or to really follow your message throughout the entire system. So correlating your messages, your calling is key here. We also rely heavily on alerting, and this is a view within Azure Monitor where you can see a timeline of issues when what happened. But basically, we use these standard alerts of the platform. For example, as soon as a dead letter, as soon as there is a dead letter within the system, we immediately get a warning by email notifying us that there's something wrong. And then, yeah, you can see here over a timeline when those happen. And yeah, this is really a nice view of Azure Monitor. So another thing that is important, or that we found it important, is, as already said, we're working with a lot of companies, a lot of users. We give out a lot of client ID, client secrets, and we had issues following that up. We have a practice of handing out secrets that are only valid for 3 months. So it's a bit of a hassle of following that up. And that bit us like a couple of months into the platform, where someone was able not to reach us because his secret expired. We didn't have proper monitoring in place. So what we did is, by using a custom-made function, we go into our Azure B2C and then take all the app registrations. I believe we're around 200 right now. And then we monitor when the secrets will expire. We get the proper email day to day, and we basically have an overview of what's going on within the system, when secrets will expire, and then we can properly notify our partners on a day-to-day basis. Talking about correlation and monitoring, some interesting story I wanted to share with you. At a given point, we received a message from an integrator to the platform saying, okay, why are my messages not being processed? I've put them in the platform, but I don't see something coming out in the end. We started investigation, and we really didn't see anything wrong. We didn't have dead letters or anything like that. So we go back to the customer and ask, yeah, can you give us some correlation ID? When you call us, we give you a correlation ID. Can you give it to us so we can further investigate? Surprisingly, that customer wasn't aware there was a correlation ID flowing back. So we were really in the blind there. So what we did is, we digged a bit further, and we opened up API management, and we started looking at some of the metrics over there. And for some reason, at a given point, that client started receiving unauthorized requests. Important to mention is, with that client, we got client secret encryption, and unfortunately, they forgot to notify us that their certificate was renewed. And that's of course important when you do a validation on those things. So here again, what I was trying to say is that you are handing out correlations, but also don't rely on your partners that are integrating to be aware of that or to give you all the answers that you need. Just make sure that you have enough monitoring in place within your system to handle all those things. So some of the key things that I wanted to share with you today to round up. Assume change. When building a platform on Azure, on the cloud in general, or building a platform, just be aware that change will come. Whether it's a service that is being deprecated or a new service that arises that maybe is a better fit for your solution, or new business requirements that can influence your current design and so on. So be flexible enough from a design perspective, from a code building perspective, from an architecture perspective, to take in those changes, because change will come. Assume failure. I've talked about that many times today, is that things will fail. Even if you rely on main services like Azure B2C or Entra ID, some of these services will have a hiccup at some point. If you build around that, or you can handle those failures, or or you work with retries, just make sure that your system is ready to fail and can recover from failure. And then maybe the most important thing is build it, run it, own it. So if you're building a system, go in there with a mindset that you need to run it on your own, and you need to support it at some point. Because then you will always think twice on how you implement things like monitoring, alerting, and so on. And that's a key thing that it's a bit of a mindset when you start building for cloud or start building an application. You just need to take ownership of it and be ready to support it on your own. So with that said, thank you. I'll have some time for questions. Or not.
2 minutes.
2 minutes for questions. Or you can drop by